Welcome back to our fourth lesson. Today we're going to cover while loops. So our first problem consists of a computer picking a number from 1 to 20, and the user has to try to guess the number in the least amount of tries. Our second problem is to find every prime number of a given number, and our third problem is called Hailstone numbers. So essentially, the computer, or we, pick a positive integer, n, and if it's odd, we multiply it by 3, then add 1. If n is even, then we divide it by 2. And the positive integer obtained is the new n, and this is repeated until the number becomes 1. And so you have to determine the amount of times or the number of operations before n becomes 1. So while loops and for loops, the logic is quite similar because we're repeating through the code within the brackets in a certain amount of time. However, in this case, we don't know the amount of times that the code should repeat. So if we have an arbitrary number, we can call that x. So while, let's say, x is less than 5, we can ask the computer to print out this number is less than 5 a certain amount of times, and in order to go through all the conditions, we can do x++ to add. And then once x is equal to 5, once x is equal to 5 or x is greater than 5, most likely equal to 5, then the code will break. And by breaking, it means it just goes to the code underneath it, or it stops, or whatever. So that's essentially while loops. Again, the logic is quite similar to for loops. The only difference is that we don't know the amount of time the code should iterate. And since a while loop is quite similar to a for loop, we can actually convert a while loop into a for loop. So for example, the initialization variable, it's the same like that. So except in the while loop, it will be before the loop itself. And in the for loop, it will just be a loop variable, so it will be within the brackets. And for the condition, it's within the brackets, like so. As you can see, I is less than 5. And then for the update condition, it just has to be at the end of whatever code will be in here. So this could be multiple lines, but at the end, you have to have the update counter. And the same thing for loops. So that's essentially how you can convert a for loop into a while loop. And the best way to understand this is to go through some examples. So before I started, I imported the Java package to get the scanner because we're going to need user input to see if the number that they choose is right or wrong. Of course, we need to initialize our scanner or create it, so I'm just going to call it insc new scanner system.in. Again, this is just a memorization thing to create one. And before we get started, since the computer needs to pick a random number, we need to create that. So you can pause the video here to try it if you'd like. Okay, so for the random number, first we need to initialize it. So we're going to do int random, let's call it that. You can call it whatever you want. And we're going to initialize it to a value of 0. Just so it's simpler or more organized, I guess. And so for the random number, I'm going to include math.random, and I'm going to multiply it by 20 because normally it's from 0 to 1. And I'm also going to add 1 because without this it would just go from 0 to 19, but again I want it to go from 0 to 20, so I'm adding 1. And since this is an integer, we need to make this an integer by doing int, like that. So that's how we can create a random number from 1 to 20, and we can just test it out quickly to ensure that nothing's wrong. Let's run it real quick. And as you can see, it's 16, which is a number between 1 and 20. So we have that. I'll just comment this out for now. And so we want to let the user know what they want to do, or at least what we want them to do. So you can do, just ask them, enter an integer between 1 through 20. Let's just do 1 through 20, like so. And do colon to make it look more interactive. And so we can add another variable, which I'll call usernum. And again, before I need to do this, I need to initialize it. So I can either do int usernum, or I can initialize it up here. And I prefer to use it up here. It's just a preference, but I like to keep track of the variables I'm using this. Okay, so usernum, so we have to get the standard, the next integer. So now we have the user integer, and we also have the random number. So random number, user guess. So we have essentially two, I guess, distinct cases. So one case would be the user guesses the number in one try. Another case is the user guesses the number in, I guess, 2 or more tries. So these are the general cases we need to deal with. For if the user guesses the number in 1 try, you can just use a simple if statement. So if the usernum is equal to the random number for the first time, we can simply just print out correct. However, it's likely that the user isn't going to pick the number in try. So we can actually use a while loop for this. So we don't know the exact amount of tries the user will use to guess the number. So what we can do is while the user number is the opposite of this case. So while the user number is not equal to the random number, and again we can use not by using this exclamation point and this as equal. So while it's not equal, we can just count the amount of tries. For the trials, I'm going to initialize variable again, but this time, instead of initializing it to 0, I'm going to initialize it to 1, because no matter what, the user is going to use 1 try to get it. And I can also add it here. So you can say you guessed it in 1 try. So we know that this if statement is going to run only if the user has guessed it on the first try. So we don't need to use the trial variable here. You can if you want, it's just in trial, just concatenate it and try, like so, add spaces. We can do both ways, doesn't really matter. And now we can move on to the while loop. So while the number is not equal to the random number, we can add 1 counter to tries. So trial. And then we can ask the user to guess again. So enter your guess, like so. And of course, we can do usernum, scanner, next int. So this will essentially repeat until the user has guessed the right number. Now, if the user has guessed the right number, obviously they don't want to be in this endless loop of just guessing the same number over and over again or guessing every other number. There's no point in doing that. So we can use the same if statement condition here. So if the usernum is equal to the random number, we can do system, we can just print out and tell the user, congrats, you guessed it in, and in this case we need to use the trial variable because we don't know the amount of times that's going to take for them to guess it. And to leave this while loop, there is a simple line of code you can use, which is just break. It does what it says it does, it just breaks out of the while loop and essentially ends the program. Yeah, I guess we can run this with the random number and hope that we get it in the right amount of time. So let's count while we try this. So let's count the amount of trials it takes for us to guess. So just guess 5. 1, 2, 3, 4, 6, 7. So let's see. The number was 7. Since the number was 7, we did 1, 2, 3, 4, 5, 6, 7. So we guessed in 7 tries, which is correct. There is a better way to improve this program. So instead of letting the user just question if they got it right or wrong, you can just give a simple print statement saying m.out.println, just simply incorrect. Try this again. Might take a while, and it's just random numbers. Incorrect. 2, so this is go in order to make it easier for us to keep track. And voila. So as you can see, we guessed 1, it was incorrect. The computer asked them to guess again. 2, incorrect, and this just repeated until the user guessed the number in 6 tries. And that's essentially how you solve problem 1.
Alright, so today the problem that I am going to be doing is a problem that asks us to find every prime number before a given positive integer. We know that given positive integer means that we will be asked to accept an input of an integer, which means that we will need to use a scanner. So I am going to import the scanner, and I'm going to type out the scanner stuff first and foremost. Again, you can copy this from your previous codes, copy it from this program. You don't need to know what it means for now, at least this part of the code. And let's see, so we will be given a positive integer. Again, how I do problems is that I go step by step. So we do the easy steps first, and then we move down and start to think about how to work on the problem, how to do the logic of the problem as we go along. So now I'm gonna have int input scanner.next int. This way I know that this is the input integer we're given, and then we want to find every prime number that is before it. So the idea of finding every prime number before it means that we probably want to loop through every prime number and then test if that prime number is a positive integer or not. And to do that, we will need to loop through every integer before this positive integer. And there are 2 types of loops that we've learned. There's the for loop and there's the while loop. In this case, both of them would work. So if I were to make a for loop, I would do for int I is equal to 0. I is smaller than the input I plus plus. And then actually instead of I is equal to 0, we know that prime numbers start at 2, so I'm going to start this at 2. So the smallest possible integer that can be prime is 2, that's why I'm starting at 2. And then I'm stopping right before the input number. So this would be one way to do it, and we would use I as the number that we would be testing to see if it is prime or not. However, this is a lesson on while loops, so I'm also going to show how to do this part using a while loop, and we will probably stick with that. I will say that typically I would probably use the for loop. While, so in this case I'm going to need to have int some number, some variable that we'll be using to test if it's prime or not. So I'll say test prime is equal to, so again we want to start with 2, so I'm going to start with 2. And then I'm going to say while test prime is smaller than input. And the first thing you want to do when you write a while loop and you have something like that is to do something to make sure that the while loop won't go on forever, because that is a very common mistake, a very common way of making a mistake, and you really don't want a while loop to go on forever. So I'm going to start this by saying test prime plus plus. So I'm going to increase it by 1 at the end of everything else I do with my while loop. This way it will eventually reach the value of input and then stop. So next we want to think about how do we see if a number is prime or not. Well, a number is prime if it has no factors other than 1 or itself. So I would have to test every integer below it to see if it is prime or not. Now, I'm sure there are other more optimal ways of solving it. This would be the easiest, most straightforward way to think about it. It would also be the slowest, and that is the level that we are going to be looking at for now. So to test every integer before a given test prime number, I would need a while loop. So let's say while, again, I'm going to need to declare some sort of integer. Let's say integer test factor. I'm going to start it at 2. Again, we don't want to start this at 1 because we know that if it can be divided by 1, that's still fine. That's still potentially a prime. So I'm going to say, well, test factor is smaller than test prime. And this is the benefit of while loops. We can do this. We could also use a for loop, again, in pretty much the same way you would do it. Next, I'm going to do test factor plus. Again, we will increase by 1. Next, I want to write out the code before the test factor increment. I want to see if test prime is divisible by test factor. So I'm going to say if test factor. So to see if something is divisible, the most easy way to do it would be with the modulus, since the modulus operand gives you the remainder of a given division. And we know that if the remainder is 0, then it is divisible, and if the remainder is not 0, given a division, then it is not divisible. So I'm going to say if test prime modulus test factor is equal to 0. That means that there is a factor for test prime that is not 1 and that is not itself, because test factor cannot be 1, and the loop is going to stop before test factor is equal to test prime. Therefore, this would mean that test prime, this number is not a prime number, and therefore we would want to say that we could leave the loop because we've already tested, we know it's not a prime factor, we're good. So I'm going to say break. Break means it's going to exit out of the nearest loop, so in this case the while loop here, that's what the break word means. So once I'm done this, I don't need to keep looping anymore. I already know that test prime is not a prime number. Next, I need to figure out a way to save the information. I need to make sure that I know that it broke out of it and it didn't just finish the loop naturally. So how I would do this is that I would add a boolean. Boolean is prime. And let's start by setting it up as true. So if this isn't affected, if it does not break, then it is going to just run through all of this and the boolean is prime is going to remain as true. However, if there is a factor, then what I can do is, like I said, is prime to be equal to false before the break. Careful to make sure to do this before the break. This means that it's going to set prime to be false, and then it's going to break, and that's going to keep the information we need. And is prime is going to reset to true every time we test a prime number. That's why it's before this loop, but not before this loop. Now that we are given a prime number, we can go on to here. We know whether test prime is a prime or not prime number here by this point in the code, because we know what the value of is prime is, and therefore we know that if it is a prime number, then we want that. So what I'm going to do is I'm going to go up here and I'm going to add an increment called int prime counter. And I'm going to start that at 0. And every time we test a prime number, so I'm going to say if is prime. So this is the same thing as saying if is prime is true. You don't actually need to write the is true, because is prime is a boolean and if statements work just given a boolean. So this is enough to say that if test prime is in fact a prime number, then I'm going to increase my prime counter by 1. And now that I have a prime counter, and remember to put this before any of your while loops, because if you don't put prime counter before any of your while loops, then it's going to reset to 0 every time, and you don't want that. Whenever you're initiating a variable, wherever it is, you need to think about where do you want it to reset? Which loop do you want it to reset? In this case, we want to keep prime counter until the very end, because once we are done with our final while loop, we want to do system.println prime counter, because that is what we are trying to find. And this should be our code. Now, one thing that you need to think about once you have this finished code, hopefully perfect, and then we need to look at the exceptions, and we need to consider what happens if it's 2. If it's 2, then it is going to skip through all of this, and that's because 2 is a prime number, and every positive number before 2, which is 1, is not prime, and that's fine. So we know that the edge case of input being 2 is fine, and you need to keep thinking through all of the edge cases, usually whatever, give your while loop an equal or something smaller than whatever your increment, your starting value is, or anything else that might cause a bug. If you can't think of anything, it's always worth just trying random input values once you run the code and see if that works or not. So I'm going to try here to see if my code works. So I'm going to have to first input a number, and let's say I want to give 9. And that gives me 4. Are there 4 prime numbers right before 9? We know there's 2, we know there's 3, we know there's 5, we know there's 7, which is exactly 4, correct. So that would be the perfectly working code. And if I were to try 2, which should give me 0, it gives me 0, good. If I were to try 14, then I get 6. So after 9, we also have 11, and we have 13, which is 2 more. 4 plus 2 is 6. Therefore, we can see, given these test cases, that our code appears to be working, and I can't see any problems with it, so this should be our finished code. Now, just for those people who are curious, this is how the code would look like if you were to only use for loops instead of while loops. And a quick breakdown can show you that this code has a lot less lines because you don't need to initiate a variable, and you don't need to spend a line initiating a variable, and you don't need to spend a line increasing the variable by 1. All of that is done in the for loop part here. On the other hand, it's also a bit harder to read because you could just use I and j as your variables. You don't have test prime, you don't have test factor, so you're not sure what each variable means. So that is entirely up to you how you would like to write it. Both ways work. Both ways don't make much of a difference at all. Each have their own ways of making it easy and common mistakes. I know personally, I like to use for loops more often, but that's just because there are more cases where for loops are useful than while loops, so it pays to be more comfortable with them. But again, slightly less readable, slightly less lines. Up to you. And that's it. And as you can see that my test values return the exact same values. Both of them work in the exact same way.
So here is a DMOsh problem. It's worth 3 points and it's called Hailstone numbers. So the goal is to pick a positive integer n, and with Hailstone numbers you would do these operations. So you multiply it, if it is odd you multiply it by 3 and then add 1, and then if it is even you divide it by 2, and then this is repeated until that number becomes 1. And so all the numbers generated from doing this operation are called Hailstone numbers. So for example 3, we can look down here. 3 is odd, so you multiply by 3 and you add 1, that's 9 plus 1, which is 10, 10 divided by 2 is 5, and that continues until it reaches 1. And this is a phenomenon that happens with all numbers. If you do these operations on it any number of times, you get down to 1. And the goal here is to count how many operations it takes till it reaches 1. So for 3, that's 7 because you have produced this many numbers, which is 7 numbers, and that's how many operations you have to do. So let's code this. So into the editor, we are going to first import java.util to get input star. Now we're going to say public class GOG, public static void main string brackets args, and then we're going to make our scanner. So scanner x is equal to new scanner system.in. Now we have to collect that integer n, so we'll call it int n is equal to x.next int. And now we have to perform operations, but we have to count how many operations it takes. So I'm going to make a count variable. I'm going to set it to 0. And then we're going to do a while loop with this. So while that number n is not equal to 1, we're going to perform the operations. If it's odd, multiply by 3, add 1. If it's even, divide by 2. That's why we're going to use a while loop, because we don't know how many operations we're going to need. So while is going to make it so that we can have many tries, and we don't need to know the exact number of operations that are to be performed. So now we're going to write if n modulus 2, so modulus gives you remainder. I don't know. Modulus 2 is equal to 0. So if the remainder, when you divide it by 2, is equal to 0, that's obviously an even number. You're going to say n is equal to, n divides equal to 2. So that's the same thing as saying, if you're more comfortable, you can also write n is equal to n divided by 2. But I like the short form notation of divide equals to 2. And then we're going to have, for our odd, we're just going to put an else there, because if it's not even, then it must be odd. We're going to say n is equal to n multiply by 3 plus 1, and that's going to be for n, and then whatever, if it's the even operation or the odd operation, it doesn't matter, we will have to add to the count. And then we're just going to simply print out that count. So let's go to system.println count. And the example that they gave us was 3, and what's supposed to happen is our operations should be 7. So there, it works. And if you can test this out with any other number, you can pick like 4. That'll only be 2, and I can prove that because if it's 4, then the next number has to be a 2, because you divide by 2. 2 is also even, so you divide by 1. We divide by 2 and you get 1. So if we don't count the 4, which is what we initially put, that's just 2, 1, that's 2 operations. So our system seems to work, and we can test that out. But yeah, we're basically just using the while loop because we don't know how many iterations we're going to need. It could be as much as 700, or it could be 1. It doesn't matter. So when we don't know how many operations we need to do, we'll use the while loop, because it will just keep this code running as long as some condition in these variables is met. So as long as n is not equal to 1, the code in this one will just keep running as a loop, and that's why we would do that. Now we're going to try and submit a solution, try and see if it works. And we're in Java 8, yep, let's see if it works. So we're just gonna keep running. Yeah, seems to be nice. Okay, cool. So that is how you would solve Hailstone numbers.